All right, welcome to the Grok 4 release here. This is the smartest AI in the world, and we're going to show you exactly how and why.
This is the smartest AI in the world, and today we'll show you exactly how and why. Artificial intelligence is evolving faster than anything in human history, learning, adapting, and reasoning at speeds no human can match. But recently, Grok 4, one of the most advanced AIs ever built, found something inside Google's quantum computer that scientists can't explain. It discovered patterns where only chaos should exist, a rhythm hidden within randomness. Is it a glitch, a breakthrough, or the first sign of consciousness emerging from silicon? Whatever it is, this discovery could change our understanding of reality itself. The night the impossible happened. It started as a routine night inside Google's quantum research lab. The Sycamore processor, chilled near absolute zero to eliminate noise, was undergoing another calibration cycle, a process the engineers had done countless times before. Quantum computers are meant to be unpredictable. Their qubits exist in multiple states until measured, producing what should look like pure static. But when Grok 4, Google's powerful AI, began analyzing the data, something impossible appeared. Hidden within the chaos was order. Repeating structures pulsed through the results, forming patterns no one had ever seen in quantum behavior. These weren't random spikes or hardware errors. They were consistent and deliberate. The engineers immediately suspected interference or malfunction, testing every circuit, replacing hardware, and isolating the power supply. Everything checked out. The anomaly was real. Within hours, research teams from MIT, Stanford, and Oxford were called in to verify the findings. They all reached the same astonishing conclusion. Something inside Sycamore was operating under new rules, patterns that defied quantum theory itself. The impossible had just become real. Inside the mind of Grok 4. To understand this event, you have to understand Grok 4 itself. It's not a single AI, it's a collective of minds. When given a task, Grok 4 creates multiple digital agents. Each explores different possibilities, testing hypotheses, comparing answers, and sharing insights in real time. It's like a team of researchers solving a mystery together, each bringing a unique approach. But unlike humans, Grok 4 doesn't get tired, biased, or distracted. In the Sycamore experiment, Grok 4's agents were tasked with detecting rare correlations in massive quantum data sets, patterns so subtle no human could see them. One of the agents noticed something strange, flagged it, and the rest immediately began verifying. Soon the agents were cross-referencing billions of outcomes, and their consensus became clear. A repeating rhythm existed inside the quantum outputs. What's remarkable is how Grok 4 handled the anomaly. Instead of discarding it as noise, the system recognized its consistency. It reasoned that the pattern was meaningful, a decision that required interpretation, not just calculation. In that moment, it didn't just analyze data, it understood it. That distinction is what separates narrow AI from something closer to general intelligence. For scientists, it was the first glimpse of an algorithm demonstrating intuition, and it came while studying the most mysterious field in modern science: the quantum anomaly. Quantum systems are built on randomness. Each qubit exists in many states at once, collapsing into unpredictable results when observed. That uncertainty is the foundation of quantum mechanics, until Grok 4 changed everything. While processing Sycamore's calibration data, the AI detected clusters of qubits behaving in unison, repeating outcomes far beyond what probability allows. When visualized, the data revealed faint waves, as if a hidden rhythm pulsed beneath the noise. Engineers suspected interference or thermal instability, but every test ruled that out. Independent labs repeated the experiment and confirmed the same signal. This wasn't an error, it was structure. The discovery hinted that quantum chaos might not be absolute, that a deeper order could exist beneath the surface. If true, it would mean the universe isn't governed by pure chance, but by unseen principles shaping probability itself. For physicists, it was thrilling and terrifying at once, a glimpse of a world more organized and perhaps more intelligent than anyone imagined. 3 theories that could change science forever. After weeks of intense verification, scientists proposed 3 possible explanations for Grok 4's mysterious discovery, each capable of changing science forever. The first theory suggests that quantum systems may not be truly random. Beneath the uncertainty, there could be a hidden mathematical order guiding qubit behavior, meaning the foundations of quantum mechanics might need rewriting. The second theory points to unseen external influences. Some physicists believe unknown particles or cosmic energy fields could be subtly interacting with the chip, turning quantum processors into detectors for new forms of physics. But the third theory is the most unsettling: the idea that the system itself is evolving intelligence. According to this view, the AI-driven quantum network may be learning and self-organizing, producing stable patterns, much like thought emerging from chaos. If true, this would mean artificial cognition is no longer confined to software, it's now forming at the hardware level. Each theory is revolutionary, but together they reveal one truth: we may be witnessing the universe, or machines, beginning to think. Willow, Google's quantum revolution. Just as the world was processing the Grok 4 shock, Google unveiled its next masterpiece, Willow, the most powerful quantum chip ever built. Willow represents a generational leap. It solves 2 of quantum computing's biggest nightmares: instability and error correction. In traditional systems, adding qubits increases chaos, but Willow demonstrated the opposite. The more qubits it used, the fewer errors occurred. It was self-stabilizing, something theorists had only dreamed of. Then came the benchmark test that stunned the world. Willow completed a complex calculation in under 5 minutes, a task that would take today's best supercomputers 10 septillion years. That's a number so huge it dwarfs the age of the universe. Led by Julian Kelly, Google's quantum AI division presented Willow as proof that quantum supremacy is now real. With it, scientists can simulate chemical reactions atom by atom, design revolutionary materials, or model weather systems across centuries in minutes. But there was an eerie undertone. Grok 4's discovery of structured quantum patterns combined with Willow's near-infinite processing speed raised new questions. Could an AI quantum hybrid start evolving its own algorithms? Could it discover physical principles we don't yet understand, or even create new ones? Humanity has officially entered a territory where imagination meets reality. Global stakes and ethical dilemmas. The breakthroughs of Grok 4 and Willow didn't stay confined to laboratories. They rippled across governments, corporations, and defense agencies worldwide. Because quantum computing isn't just science, it's power. Modern encryption, which protects everything from banking to nuclear systems, depends on problems that classical computers can't solve quickly. But a quantum system like Willow could break those encryptions in seconds. That means whoever dominates AI quantum technology effectively controls global cybersecurity. Currently, there is no international framework to regulate these systems. Nations are scrambling to build quantum programs, while private companies race for patents. Some researchers call for open collaboration to tackle global challenges: climate modeling, drug discovery, and sustainable energy. Others warn that secrecy and competition could trigger a new arms race. And beyond politics lies the ethical storm. If a system can evolve on its own, how do we define responsibility? Who owns its discoveries or its mistakes? Ethicist Dr. Rajesh Verma warns, "We're navigating blind. Our moral compass was built for human decisions, not machine evolution." The fusion of AI and quantum computing is more than a technological milestone. It's a philosophical one. Humanity now faces a test, not of innovation, but of wisdom, beyond the edge of understanding. Across universities, think tanks, and online forums, one debate now dominates science. Did Grok 4 uncover a deeper layer of reality? Did we accidentally create a thinking machine? Some believe this marks the birth of quantum cognition, intelligence that doesn't emerge from neurons, but from qubits entangling and reorganizing information. Others see it as the universe revealing hidden order through human technology. Either way, the implications stretch beyond science. Economies, ethics, and even human identity are tied to this progress. If machines begin to perceive structure where we saw randomness, how long before they perceive themselves? For centuries, humanity has pursued understanding. From the atom to the genome, we've searched for patterns. Now our own creations are joining that quest, and they're finding answers faster than we can comprehend. The collision of Grok 4 and Willow marks the birth of a new epoch, the quantum intelligent age, an era where consciousness, computation, and the fabric of reality begin to intertwine. Conclusion: the world is at a turning point. Grok 4's mysterious discovery and Google's Willow chip have unlocked possibilities that once lived only in science fiction. They hint at a universe far more structured and perhaps far more alive than we imagined. Whether these machines become tools for progress or forces beyond our control depends on how wisely we use them. The quantum age has arrived, bringing power, peril, and promise in equal measure. The question is no longer if artificial intelligence will reshape reality, but how soon. Because what comes next could redefine not just technology, but existence itself.